Alright, today I'll explain you solid state questions which you can expect in CSIR. Before we solve those questions, let us quickly revise the few basics which are required to solve those questions. Okay, as we all know, there are three basic unit cells: simple cubic, face-centered cubic, and body-centered cubic unit cell. And when we look at the contributions of the each unit cell, this I'll try to explain from a diagram which I tried here. So let us consider this blue as a reference. Just forget the blue one and just have a look at the four other cubes which are present here. And if you look at this corner is shared by second cube, first cube, third cube, and fourth cube. So one corner is shared by four cubes in the front side. This is 2D view. In the 3D, the same corner will be shared by other four which are behind this paper. Okay, so one corner is shared by 8 unit cells present in a cube. So the contribution is there are 8 corners present in a simple cubic unit cell. Each corner is shared by another 8 unit cells which are attached to it. So 8 into 1 by 8, it will be equal to 1 atom. Face-centered cubic unit cell, in this the atoms are present at the corners as well as at the center of each face. So there are total 6 faces, as we all know. And here is the explanation. Like, I wanted to explain why the contribution is 1 by 2 for each face. If you look at this particular face, which is shaded region, this is the face shared by third unit cell as well as fifth unit cell, right? So common face for both the unit cell. It means there are 6 faces into 1 by 2, that is 8 into 1 by 8 as such of this, plus 6 into 1 by 2, 4 atoms. Okay, and then body center again at 8 corners, and one is present at the body center which is not shared by any atoms. Hence there are total 2 atoms for body center. Okay, and then tetrahedral voids. So tetrahedral voids are located along the body diagonal, and each body diagonal has 2 tetrahedral voids. Okay, like this. If this is a body diagonal, definitely there will be 2 tetrahedral voids. So the general formula is 2Z. Z is the number of atoms. For simple cubic, it will be 2. For this, it will be 2 4s are 8. For this, 2 into 2, 4 tetrahedral voids. Octahedral general formula is Z, and that means number of atoms is equals to number of octahedral voids. I've solved the example for FCC. For FCC, like the contribution of the octahedral void for FCC is 1 at the body center and at the edge center. So 1 plus 12 into 1 by 4. So there are 12 edges in a cube, and contribution of each edge is 1 by 4. How is it 1 by 4? You can see if this is the edge, this is shared by this cube as well as this cube. So this is the 2D view. This is the front 2 side, another 2 behind this paper. So total 4. So 12 into 1 by 4 is 4. Okay, if you know these things, you can easily solve the question. So in a compound, atom of element Y forms CCP lattice. FCC or CCP is one and same, and those elements X occupies 2/3 of tetrahedral voids. The formula of the compound will be, so Y forms CCP lattice. CCP is here this thing, 8 into 1 by 8 plus 6 into 1 by 2, 4 atoms. And those elements X occupies 2/3 of tetrahedral voids. So in CCP, we know that there are 8 tetrahedral voids, as I explained here. 2Z, 2 into 4, 8 atoms. So that's what I have written here. 4, 8 into 2 into 1 by 3 is 16 by 3. So X is to Y is equals to 4 is to 3. Now a little tricky question. Then a crystalline solid atom of X forms FCC packing, and atom of Y occupies all octahedral voids. If all the atoms along one body diagonal are removed, then the simplest formula of crystalline solid will be. So we know that along the body diagonal there are 2 corners present and 1 body centered. Okay, in FCC there are 8 corners, but if you remove 2 corners, you are left out only with 6 corners. So 6 into 1 by 2, 1 by 8 plus 6 into 1 by 2, that is 6 faces. So the total is 15 by 4. And if all the atoms along one body diagonals are removed, so one octahedral void is also removed as it is present on the body diagonal. So y is equals to octahedral void, that is body center plus edge center, as we have seen in the previous page. So there is no body center as we are removing the one of the body diagonal atoms, so that will become 0 plus edge center is 12 into 1 by 4, 3. So x is to y is equals to 15 by 4 is to 3, that is 5 is to 4. So the option is C. Thank you.